Now go ahead and go into Blender. Also, go into Spider. Spider's this icon, looks like a spider web. Today we're going to look at the little bit of the programming behind what you can do in Blender. It's with a package called, or a programming language called Python. And we're going to use a package called Spider. Really? For what?
Spider.
Looks like it is based upon a network. We allow the Anaconda system is one you could actually, which includes Spider, is one you can actually install without admin rights. You go to the library and install it, and so forth. Which I've done one time. I never bothered cleaning it up either, so they're probably still going to stay looking at it. So what's a Spider? Okay. Now, if I do the drop down up here, I can choose a scripting option. Remember, these options gives you the best windows for different items. It's a little hard to see, but down here in this black, if you put your mouse in the upper right-hand corner until it becomes a little plus, click and hold down, you can drag it to create a new window there. And then, if I choose this option here, I can choose info. Now up here is where we're going to write our Python program at, our different programming language. We're going to do some of it over in Spider just to get used to the programming language, because this is not as robust in terms of showing us display and so forth as the other one would be. To create a new Python script, you see this button here says plus new. So if you click that, that'll create you a new Python script. Now I got my cube here. I'm going to do a X for delete, and then I'll choose delete. You notice down here it says bpy.context.area.type equals info. What that was is just choosing the info window. And then bpy.ops.object.delete, use global equals false. That's what deleted that cube. So if I come up here and I do a Shift A and add a cube back in, over in my Python window here, I can type. I wonder if there's any way to make that bigger. There. I'm holding down my control and mouse wheel. I can import BPY, and then I could say BPY dot OPS dot object dot delete. Now, sometimes you do not need all the parameters that they put in. They say use underscore global false. I wonder if I can make that bigger so you can see it down there. Nope. Have a shift. Nope. It's as good as it gets, I guess. Okay, so I got this code here. My cube is selected, isn't it? If I run this, you may have to scoot your window over to see it. If you scoot it over to the right, you see there's a button that says Run Script. If I click Run Script, I got an error. Look at the console for now. Maybe. I didn't think you did, but use global. Oh. If I wasn't blind. It's not BYP, it's BPI. Or BPY. Now let me click Run Script. And you see, my cube got deleted, didn't it? Now I'm going to do another Shift A and choose Add, and then choose a cube, put it back in. Now instead of the cube being selected, let me right-click the camera up here. So I right-click the camera. Now if I run the script, you see a camera disappears. So whatever you have selected is what gets deleted. I can right-click the sun up here. And if I run the script, you'll see the sun disappears. Okay, I'm going to run the script one more time, delete the cube. I don't know if there's any way to clear this screen. I don't see a way anyway. But let's add a cube back on. So I'm going to do Shift A, choose Add Mesh Cube. And you see down here, it says bpy.ops.mesh.primitive_cube.add, and then it's got a lot of different parameters here. I thought there was a radius option on that. Or not, well, maybe not radius. Okay, but let me put that in here. So I'm going to delete that. It says bpy.ops.mesh. Let's hope I can spell everything right this time. Now, dot primitive_cube_add. And like I say, on a lot of these, you do not have to enter on all those parameters. Now if I run the script, if I do a G for grab, move to the side, you see it created a cube. I do another G, or not a G. I run the script again, and then I do G, and you see it create another cube. Okay, so I'm going to delete those ones I just created. Is that good so far on this? Okay. Now I'm going to run the script one more time because I actually want a cube. And you see down here just says bpy.ops.text.run_script. Now if I have this selected, I do a G for grab and move it over right there. You see, we can do bpy.ops.transform.translate, and I'm assuming that's XYZ, but that moves it to that location. So up here, after I add a cube, I could do bpy.ops.transform.translate value equals, and I'll put in -2, -3, and 0. Now I'll leave all the other options blank, but assuming we don't need all those other ones, what that should do is it'll create a cube and then it'll move it. So let me delete this one now. Okay, so I run this script, And it created the cube and moved it to a new location. This is how you can definitely use the array modifier to create like 100 cubes. But if you're wanting to create 100 cubes programmatically and have a little bit more flexibility beyond the array modifier, then you could do it from a programming standpoint. You could randomly put these cubes anywhere on your screen. Everybody get the cube created? It's easy to mistype one thing wrong. You look puzzled, like you were trying to find your error.
Well, I think I moved that one. Okay.
Move what?
Not that, but that screen up. Move it.
Oh, this right here.
Yeah.
Yeah, it doesn't wrap, does it? That's kind of bad.
Oh, because you couldn't translate entry.
And just like every other programming language, as picky as can be, if you're missing a closing parentheses, then it's not going to work. Although Python's a little bit different. If you got a programming error in any other language, it just doesn't work, period. This will work partially. So it'll go through and work the lines of code it can, but then the one that's wrong, it'll error out on.
So I had everything right.
Uh-huh.
Apparently, it was so picky. I had accidentally added in an extra period than what I needed.
Oh.
So it wouldn't let me do it.
Mm-hmm. Now, let's see. We haven't covered the for loop yet. We will cover it. So I guess I'll hold off on that. But these don't have to be hard-coded with numbers. They can be variables. I'm going to have to look up myself what the exact syntax is. Python's a little bit different. I think it's like for x in range, and then you do 1 ... 3. But just to give you a look ahead. For x in range 5. So that's where it's going from 0 to 4, I think, yeah. So I could have a for loop in here. For x in range to 4, I think you put a colon. For y in range 4, colon. For z in range 4, colon. Now, it is very picky about spacing. So that those indents have to be there. In other programming languages, you use braces to indicate what's included in a for loop or an if loop or whatever. In Python, it uses spaces. So if you delete those spaces, think, well, I don't want as many spaces there, it won't work. It'll give you an error. And instead of these, I'm now going to put X, Y, Z. And assuming I don't have to convert those to like float or something, if I do, then I'll have to hold off in this example. I have to look up how to convert it to a float. That should create a lot of different cubes. Let's see. I'll try to run it now. Run script. Doesn't like something. Oh, I did a translate, not an add. Okay. bpy.ops.mesh.primitive _cube _add. Now it might have, well, no, I think translate would have been different. Let me try to run that. So what did it create? Right. It created a 4x4. How many did it create? 1, 2, 0 to 3. I wouldn't expect it a 3x3. No, there's Geez, how many did it create? In theory, 4 here times 4 is 16 times another 4 is 64. So it should have created 64 cubes. Does that make sense, son?
Yeah, mine did do that though.
Oh, did it?
Put cubes around the original cube. Put like in front of it, above it, like above it.
Do you have the same code as me here?
Yeah.
That's Huh. How about if you right click on that big cube there, can you break it to pieces? How strange.
I thought yours was to say a whole bunch.
It worked for mine.
Did it work for yours?
Yeah.
Yours look like it put it all together.
Yeah.
Oh, it's because, see the spacing here? That spacing is not included in the for loop.
Where's the spacing?
You have to space it over until it's underneath this other BPY. Yeah, the spacing will drive you nuts on Python. Now, if you run it, it'll create all those weird conglomerations.
Yep. Yeah, it did. It did.
This is where if you're trying to create a tree or something like that, you can have it very quickly go through a while loop where it's going through 10,000 iterations and creating 10,000 different branches, for example. Okay, I'm going to select everything and then do an X for delete, get rid of all those. Best way to learn this is to play. One thing you have to remember is you have to remember this import.b or input BPY. I had to look that up this during lunch because I couldn't remember what the import was. I knew it should be there, but other than that, if you look in this info window, you're going to see what kind of command there should be. For example, if I added a cube, so I do a Shift S, Shift A, try it again, add in a cube. Of course, that's the add down here. If I do an RX and rotate it, then that tells me I got bpy.ops.transform.rotate, and it gives me a rotation there. So after I've added the cube, I could then put in bpy.ops.transform.rotate, value equals X, axis 1, 0, 0. I think the rest I can leave off, but we'll see. Maybe not. Follows keyword argument. Line 6, value. Axis equals. It doesn't like something else either. Okay. BPY. bpy.ops.transform.rotate. Rotate, not rotation. This is going to be bad if I can't make that bigger. Dot rotate, value equals. Let's try that.
Is there any way to select all of them? cubes I have, I have a whole bunch.
You do A twice or once, depending upon what you have selected,
Uh,
and then you can select them all.
yeah, it was like in the scene bar where it said all my cubes, I have 238.
238.
Yeah.
Yeah. See, that's the thing of it is oh, X won't change very much. Z is the one I probably want to change. In range of 90. Let's change that. I'll delete that. There is a way to refresh the screen so that you can see each individual movement. I'm going to have to look that up. Python, Blender, Python, refresh screen in script. bpy.ops.wm redraw timer. I don't remember that. Now, if that doesn't work, then we won't try that yet. So after I change it, then I want to refresh it. Let's try that. No, I'll have to dig into that and see. So like I said, the rotate's not going to be as clever as the add then. So if I come here, do a bps.ops.mesh.primitive cube add. If I change these to 90, I'll come over here and delete that. And if I run that, then like something line 6, bpy.ops.mesh.primitive underscore cube underscore add and extra parentheses at the end. I crashed my computer. I don't know what 90 times 90 times 90 is, but that's how many cubes it's creating right now. And it's not going to come back because remember, I don't have a refresh on, so it refreshes the screen after each change. So it won't come back until it's added. It's 100 times 100 times 100. 1, 2, 3, 4, 6. 1 million?
Yeah.
So this is probably 800,000 cubes.
Well, let's see. 72,000?
Is it 72,000? I might have been pushing it trying to do that.
Let's see. 800. No, it's 81. So
90 times
720,000.
90 times 90?
Yeah.
729,000.
Is it? Okay.
That was all 49,000.
Well, there I went and crashed the system.
Nice.
Okay, close the program. So it isn't that easy to create 1 million cubes. Nearly 1 million.
Who would have thought?
Who would have thought? Now this is, let me go back into it. We looked at the array modifier. I'm going to come here and choose scripting. And create a new script here and import BPY. I'm going to look at how to create a cube because I want to create a cube going all the way across. Looks like these are a distance of 1. It's -1, -2, -3, -4, -5, -6, -7, -8. So for x in the range, I think you put -8, comma, but let me cheat and go look at the side here. Three comma 6 goes 3 to 5. So I'm going to go to 5. 3 to 5. So that's 1 greater. So I want to go to 9. And that should go from -8 to 8. For y in range, -8 to 9. And for z in the range, -8 to 9. Now we're going to add a cube, so I need to know how to add the cube. So again, I'm going to create my info window here so I can steal the code. And I'm going to do an A. Okay, Shift A.
-8 point 9, comma
-8, comma 9. And choose cube. And looks like to add a cube, come over here. It's bpy.ops.mesh.primitive cube add. There's a radius I was thinking should be there the first time.
Well, we type in bps.mesh.
Let's see. That's what I typed in. So radius equals 1. That's curious it wasn't consistent. There was no radius last time, was there?
No.
Yeah. It's bizarre that it's not the same. Kind of bothers me a little bit, but not too much. Now I'm going to do a G for grab and move this because I want to know how to do a translate. Looks like we got come here, bpy.ops.transform.translate. And I'll say value equals, and I'm going to have x comma y comma z.
Did you get one script?
Not yet.
I wouldn't.
Yeah, I wouldn't.
Because it's not responding.
Yeah, I mean, those might crash.
Yeah.
So what's wrong with my range then? Let me see. For x in range 3 to 6 gives 3, 4, 5. For x in range, that should go -8, -7.
Yeah, I got the radius equals 1, then you moved your cube, and I thought you pressed run script, so I thought it like added another cube, so I did that, and now it's not responding.
Yeah, same. So I wouldn't.
I'll give it a little bit of time to see what happens.
I did not run a script prior.
See, now you're just challenging me. Let's see. I'm gonna have to do it now. So I don't see any programming error. Colon, colon, colon. X, Y, Z. They're all different.
It's not programming. But again, it's an error.
What if it's only -8 and not 9? Or maybe you can't have a negative. No.
You should be able to have a. I wonder if I can try it over here.
Is this what cubes?
Let's see. For X in range, -8 to 9. Let's see what it gives us. Well, that's kind of stupid. I can't do it all at once. For X in range, -8 to 9, print X. Run, yeah, there. -8 to 8. For Y in range, -8 to 9. For Z in range, -8 to 9. Print, let's see, how do I separate those commas? I think. Let's see. Oh, I guess there is quite a few, quite a few there, isn't there? How much would that be? Maybe 20 times 20 is 400 times another 20 is 8,000? Oh, okay.
Yeah. Yeah, how's yours? How's yours going, buddy?
It's still not responding.
Same.
I'm glad you guys did it and I didn't do it.
Oh, yeah.
I bet -2 to 2 will work real well. So, it's good. You guys should always test it out before I run it. That way I don't hang my computer up.
Yeah, no problem.
Now that should be a 4 times 4, which is 16 times another 4, which is 64. But just to be on the safe side, I'm going to add a copy of this just in case I have to restart. It's not quite what I wanted, though, for the translate. I'm moving this to that new position. I'm increasing these by 1.
You should try to make 9 and see if you can get results.
It'll come back, I'm sure. Give it a couple days. It'll be there. What am I translated? Maybe I want this radius be 0.5.
How come we never use your desktop?
Oh, this?
Yeah.
I don't know. I think I'm about ready to. Yeah, I'm this close. This close to it. They've given me admin rights. They actually have told me that I'm responsible for the laptops in here. So I have to install the software and breaks, I fix it, and so forth. And for the longest time, I couldn't get software to work. And I don't have admin rights to the desktop, so I can't install anything on here. So I was waiting until I got everything ironed out exactly like it should be before I call the IT people and say, come over, I need you to install this, 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 and this. So that's the reason why I don't. But I'm real close. The Introduction to Digital Design, I found a free circuit program that we can use to test with. That's pretty cool. And I think that was the last piece for this semester. Of course, then there's next semester with all the software. And so, okay, so let's see what that gives us. That looks better. 0.25. Let me try that. So again, you can very easily create that. You can create the same thing with an array modifier. So don't think there's anything like unique about this. But array modifier doesn't allow you to do some random stuff. Like if you wanted to follow a pattern, this array modifier would work out good. But if you wanted it to be random, so cubes appear randomly, then the array modifier wouldn't be as effective. You could do a lot more with the programming language. You might have to kill your Blender to get it to come back up. But never know, it might come back.
I'm curious if we could set here and see what happens.
I wish I could remember that refresh command, because if you had a refresh command, you'd actually see it drawing as it went along. So you'd see what kind of progress you're at. Surely it can't be that difficult to locate the Python refresh command. Scene update. That rings a bell. I didn't remember the redraw. Let me try that. It was so fast it didn't matter anyway. Change one of these to 20. No, that didn't work. At least it didn't update it. Well, let's start taking a look at Python now that we've just kind of explored a little bit on what you can, why we're looking at Python. Some of this will be items you've seen before. Some will be new. We're not going to look at everything with Python. That's a whole semester class. So we're just going to learn some of the basics. How's it different? Hello world. Over here in Python, if you just simply type print and then beginning parentheses and then quotes, hello world. Then if I run that, this little green right here, or you could choose run and this option, or press F5. You'll see it prints hello world over here. You can print numbers. If I do print 3, if I run that, you'll see it prints hello world and then prints 3. You can also type the commands over here. So if I type print hello world here, then it'll do that one line of code. This is an interpretive language where it processes it one line at a time, which means if I have this, I'm going to right click over here and clear the console. If I run this, it went through and did the first 2 lines of code. But it hit the 3rd line of code, and it is case sensitive, in case you're wondering, and it bombed off at that point. I don't remember what it does if you got anything after it. I usually don't leave errors in there. What happens here? So right click that and clear console. And if I run this, looks like when it hits the first error, it bombs off. Doesn't do the rest. This is a nice feature over here. A bunch of nice features for Spider. If you're trying to figure out what you're doing wrong Python-wise, if you come over here and you type it, you notice that these are a purple color, but this is not purple. That right there would tell me that I'd done something wrong. And I put my mouse over it, and there it goes. It says undefined name print. Now you can have variables, just like every other programming language. And it's kind of weird how it does it. How it declares variables is on the fly. Like num1 is equal to 7. Num2 is equal to 3.2. Num3 is equal to David. What would you say 7 is? What type data type? Integer? Number with no decimals? How about 3.2? Double? Number with decimals? Could be float, depending upon the language. How about putting quotes around it? String? That's a string. Over in Python, when you're running across something here where you see it change and it's a string, then if you're going to do that, you have to make sure you're working with a variable with string. Let me see. If I do a Shift A, choose text. I don't think we've looked at text, have we? We will eventually, but.
Or, yeah, actually, we have.
Did we? Okay. And I'll rotate it. Which way? I can't really see that. What's a red? Is that X? Okay. And 90, like that. So we got a text there. And it says bpy.ops.object.text_add. And somewhere in here, we're going to see the text. Although for the life of me, I'm not seeing it. False, inner mode, location. I can't see it there. Let me go up here. Huh. Maybe you can't change it there. Let me go and edit. Put David. Go out of edit. So bpy.ops.font.text insert. But then you have to delete. So I can put all these in here and type whatever text I want. question becomes, if I could do, probably have to go in edit mode. So bpy.ops.object.edit mode toggle. You can probably figure out what that does, right? Goes in edit mode. Probably you toggle it again, it goes out of edit mode. And then I'm going to say bpy.ops.font.text_insert. And then I'll say text equals YOY. Hopefully it doesn't have to do it a letter at a time. Then bpy.ops.object.edit mode toggle. Be nice if I had code completion here. Okay, so I got this selected. And see it tacks on YOY. Now, let's try running that again. Then if I run it again, you'll see it keeps on doing the YOY. Now here, instead of YOY, you could have a variable. My string equals Y or YOY, like that. And then here you should be able to put that variable name. And see, that does it. So again, these data types you're going to find you can use in a lot of places in programming for animations. You can create an interactive game. I'm trying to remember if it allow you to enter in text, like if it prompt you saying, "What's your name?" I don't know about that, but it would allow you to put different items on your screen, so you could push DAVID, push those buttons, and then you could get that. That wouldn't be very slick, but it would allow you to do that. So those are our variables and our data types. It's dynamic. What do you have to do in C#? int space for an integer, double, the string, and so forth. This automatically assigns it based upon what type is. That can create issues. num4 is equal to 1 divided by 3. Then you print num4. Let's see what it gave me. That might be fine. But what if I wanted that to be integer division? What should 1 divided by 3 give me? 0? Thinking of division using integers. So 1 divided by 3. There we go. How many times does 3 go into 1? 0. So it goes into 0 times, doesn't it? Then you take 0 times 3, that gives you 0, and so forth. So integer division-wise, 1 divided by 3 gives you 0. Now there's other ways around that, but some of the normal ways you think of the division, you have to maybe rethink, because it tries to guess, and it guesses, okay, I know this is an integer, but I'm guessing you want these to be a double. Like I said, there's other ways to do integer division. I'm not going to, like I say, cover every topic in these programming. Basic operators. Some of these are pretty standard. You've seen it over and over. I don't really have them summarized. But plus is addition, minus is subtraction. The asterisk, as always, is your multiplication. The this is your division. Now they put 4.0 here. Let's see why. I really don't know the reason myself. I mean, I have a pretty good guess. Because I've seen this before. It's going to do 2 times 3 initially, which is 6, right? And then you want it to divide by 4. And if you don't put the 0.0 there, I'm guessing it probably thinks it's an integer. But let's run it and see. That gives us 2.5. Let me get rid of that. Still 2.5. So that 4.0 wasn't necessary, was it? In some programming languages, in order to force it to think it's a double, you have to put a 0.0 there. By putting a 0.0 there, then it knows how to handle it. I have no clue why I put the 0.0 there. This is how to return a remainder. We're not going to do anything with that. Here's how you do power. 7 squared. You do 7 asterisk asterisk. That's unusual. Has your computer come back yet?
Oh, I stopped it all.
Oh, you did? Okay. I was just curious. So if I do 3 squared, should give me 9. Like that. If I do 7 to the power of 1.2, let's see what happens. Gives us a bunch of decimals. Operators with strings. The plus is concatenation. So if you want to concatenate some items together, then you can. Yeah, that's probably all the exciting part right there. Some basic string operations. You can return the length of your string, len. What does this do? Returns 4. Oh, okay, I know what it's doing. The index looks for the first occurrence of O. And this is at position 4 because your string starts with position 0. So that's 0, 1, 2, 3, 4. We haven't really talked about arrays yet, but we'll have to incorporate that soon. for programming. Arrays allow you to have, let's say I have 500 game objects. Well, I could have 500 different game objects down here, and let's say they're all the same. So I have 500 I have to manipulate. Is that going to take me a while? Oh, God, that'd be horrible. You'd have so many lines of code trying to anticipate that. Two ways you can handle that. One way is if they're all going to be exactly the same, but maybe just something slightly different about it, you can use an array. So you have an array of them. An array is a list. Means we only define one game object, but then we have a whole slew of them that are based upon it. So they don't all have their own individual properties, they just point to that one. Another way to do that is with objects, and that's the preferred way if you're going into game development. Objects allows you to kind of define generally what an item looks like, and then you create instances of it. For example, if I come over here, if I delete that and come over here, do a shift A, add mesh, add a cube. Come here, do a shift A, add a mesh, add a cube. Those pretty much have the same characteristics. They do, don't they? They all have a location. They have a rotation. They have a scale. All these are the same for every one of them. Notice up here, this says this is called cube, and this is called cube.001. You can double click these. Let's try that again. And I can call this cube1. You can double click this. Okay, do you want me to go ahead and...
No, you guys keep going if you don't mind about 5-10 minutes.
Oh, okay. Yeah, that's fine. So this would be cube 2, like that. Now, these are both still cubes, aren't they? Each one of these is their own instance. If you think about a video game with a lot of characters that you played, Star Wars. Didn't we mention Star Wars in here? No?
I played like old Star Wars.
Or Star Wars Lego. I'm sorry.
Yeah.
Yeah, but
Yeah. How many characters does that have in it? Like 100 or something? I mean, it's just,
Something like that.
yeah, a lot, right? You could have 100 different definitions, or the fact that they share common characteristics allows you to say, okay, they're all going to look like this, but I'll create an instance of it, and maybe I'll have some new characteristic about it. Like Han Solo. He probably does almost all the same thing as Luke Skywalker, right? But he's got something unique about him. Probably he has a gun versus a lightsaber.
Yeah.
So it's inheriting all those. If you think about it from a and I'm not very good at this, so you have to use your imagination probably. And you probably have to help me with this. Humans are what? Mammals?
Yeah.
What's a mammal?
Anything that breathes there.
I mean, I'm sorry, what's it inherited from?
Oh, what's it?
Say it's an animal. I don't know if that's true or not. So a mammal is an animal.
well, apes.
Apes.
Apes,
Gorillas.
right?
This one.
Right.
Bananas. Already.
This is the idea of object-oriented programming, is that you have a definition of what is an animal object. And then you have a mammal that inherits certain properties. And then you got a human that inherits properties. So that right there is a principle behind object-oriented programming. Now over here, you could have a cube, you could have a sphere. Question is if it inherits anything or not, and it might. Definitely, they all have a position, don't they? That's the hard part when you're designing a program, trying to think of how to do object-oriented programming. At IFR, when I worked there, the human resources department wanted a program, and they wanted it to be object-oriented. And we said, okay, well, how can we do this? And I don't think we ever came up with a good plan for it. Because an object-oriented has to be at a higher level, where you're saying you got your organization, which is a college. Within the college, you have your departments. Within the departments, you have your employees, and broke down like that. They just wanted a little segment, and object-oriented programming wouldn't work well with that. So, but that's what this is. Each time you create a cube, it creates a new instance of it. Now, it doesn't mean you can't change it after you create an instance. So after you have one of these, if you go into edit mode, you can change the characteristics of that. That still doesn't change the fact that it's a cube, does it? Remember those modifiers we would do, and it really twist it around, but it's still a cube. Now, other items we have, count. This returns a part of a string. So all these commands you're not going to do a whole lot with when you're talking about animation. But they are available for strings. Now loops and the conditions is where you're going to do a lot more. You have your script here. We talked about putting a for loop in there. If I can get hold of that. There it goes. You can put a for loop in here. You can put an if statement. You can put a while statement. Everything you've seen in your other classes in C# applies here. You just have to add in the imagination to figure out how in the world do you use this to create different shapes and different figures and so forth. So. Remember your Boolean operators? If name is equal to John, age is equal to 23, and so forth. Well, you can use those here. You can use if statements here. Perhaps you want to cycle through. Let's say you're creating a script that'll have 100 different trees, and you want to cycle through until you hit the 50th tree. You can check if the index is equal to 50, then you want to change that one tree, for example. I don't think you use a whole lot. Pretty much you'll be cycling through. Even though these all have their individual names associated with them, they also have numbers associated with them. And you can see this right here, right? Cube.610, Cube.611. I don't know what that pertains to. There is another numbering system besides that. I wonder if I add another cube, if I do a shift. Why can't I remember that? A, I think. Oh, I'm in edit. Let me do a Control Z. Now let me do a shift. A, mesh, cube. And it calls us cube.6612. Do you think it's possible you created 612 cubes since we started class? Might be. You guys are probably what, up like 90,000 or something like that? What is your numbering, by the way?
Should be around 90,000. Like I said, I saw for that.
I'm just glad you pointed out my mistake before I ran my script. But again, you don't loop through these with the names. You loop through these with the numbers. Because if you have 1,000 cubes you're going to go through, then you obviously can't hard code 1,000 names in there. Now you notice that there's a naming scheme to these. So if I come over here and do another Shift A and mesh and cube, maybe I lied to you. Cube. Oh no, that's what the naming scheme was before I renamed these. Then I do another Shift A, mesh, cube. So would it be that hard to come up with a pattern for that? No, not too bad, right? Because in your loop, you could say for x in the range, of 1, 200, like that. And remember what that's going to give you. Is this going to give you all those? Harder part is putting zeros on the front of these. Because when you try to concatenate that together with a string, you're going to need to have zeros there. Because that's exactly what these are wanting. They're wanting 0, 0, 2. They don't want just 2. Does that make sense? Okay. Then I'd have to refresh my memory myself how to change them to a string. Let's see if I can remember. New string equals David or cube. So I think they're called cube. Uppercase cube plus x. Print new string. Must be string, not integer. How do I change it to a string? Probably str. Of course, I'm missing the dot there, aren't I? And I'm guessing this one is not right up here. See, I don't have my leading 0. Well, the dot's easy. Put that there. Put a leading 0. I'd have to put another piece of code in here. I would say I need a new variable. Call it something. See, something is equal to string x. And I'll check while the, not sure if I need parentheses there, while the length of something is less than 4. It's probably not right. It probably should be 3. Then I'm going to say something is equal to something is equal to 0 plus something. Okay, so then I want to concatenate on my new string. That right there. So let's see if I'm even close. Too many. So this should be a 3. Now let's see if it handled the zeros up here. Oops. And it handled them, didn't it? That's the benefit of using the Spider package. This package over here, when we do the programming to try to control the animation, this is not going to be that powerful. It does not have all the features of the other one. I'm not even sure how you'd print. You'd print it down this little window I can't seem to make bigger so I can even see it. So you're very limited. So this package is where you should be testing your code out. You can't test everything. If you come over here and you try to do your import BPY, was that what it was? Import BPY. So it'll give you an error, I'm guessing. No module name BPY. But you at least can check this part right here. So then over here, if I grab a cube, let's see if I can figure out. That's disappointing. When I'm right-clicking it, you see it's not changing it down here, is it? I was hoping it'd tell me what the syntax was. If If I do a G for grab, if I select that, do a G for grab, looks like it's always based upon the object that's selected. So we'd have to research that. We'd have to see, how do you select something by name? Let's see, Python scripts, cities. Now, I mentioned this already. Let's try this one. Well, but generate cities. Oh, I didn't put Blender in there. Here's a city builder. This is where you can take a script and you can generate an entire city. Now, I've used these before, and they're pretty slick. You just tell it like how many blocks you want. You want to tell it how many trees you want and so forth. This one doesn't have a tree one built into it, but then it'll generate it for you. Really, what you'd have to do if you want to use this, both of you indicated to go into game development. If you were to work on that side, like you had your artist say, we really need something to generate these cities. It's taking us forever. You could take an existing script, and that's the idea on open source, is they want to share. They put this out there for you. And you just need to figure out how to tweak it. You look in the code, and you see, okay, yeah, this does this, and that does that, and then you change it appropriately. There's ones to build trees. Those ones are pretty cool. And we'll look at these in coming classes. I don't know if this will actually show running one or not. Let's just see. Assuming I could turn the volume on. Oh well, you'll see the picture anyway. So you don't have to even be a programmer for some of these. You notice what it's asking us: how many branches do you want? How many nodes? What kind of angle? The screw angle, angle 1. Do you want things to look random, or do you want them to be generated symmetrically? As you go through and change these, you'll see it generates more branches or less branches as you change the numbers. And you see here in the background is just our things we started looking at already. bpy.props.float, so forth. Some of the items we've looked at really don't have a whole lot to do with animation, but you have to understand some of the feature set. You have to understand some of the feature set in order to understand the programming behind it. So. Is there any questions on any of that? Okay. Well, we'll go ahead and call it quits there. I'm getting the wave down. So let me go ahead and stop the recording.